How to balance chemical equations in 5 easy steps. Step 1. Count the atoms on each side of the equation. Let's count each type of atom. Sulfur, I have 8. Oxygen, I have 2. On the product side, sulfur, I have 1. And oxygen, I have 2. Note that if there's nothing after an element, we assume that to be 1. And that's it. We're done with the first step. Smooth. The big rule for balancing equations is that we can only change the coefficients. Those are the numbers in front of the atoms. The numbers after the atoms, the subscripts, cannot be changed. So let's balance this equation by changing the coefficients. If there's no coefficient written, we assume that it's 1. So right now there's a 1 in front of each of these terms. We can see that we have 2 oxygens on each side of the equation. So the oxygens are fine. But the sulfur atoms, we have 8 on the left side, the reactants, and only 1 on the right. Well, to fix that, I can change the coefficient in front of the sulfur on the right and make that an 8. So if I put an 8 here, that means 8 times the 1 sulfur. That'll give me 8 sulfurs. And now my sulfurs on both sides are 8. But this 8 here is also times the 2 oxygens. And that gives me 16 oxygens. So I've fixed the sulfurs, but the oxygens aren't balanced. I can change the coefficient here, though, to 8, because 8 times 2 equals 16. So now I have 8 sulfurs on each side, and I have 16 oxygens on each side of the equation. This equation is balanced. Step 3, so you don't forget, only change the coefficients. Let's try another problem. So in this equation we have 2 hydrogens, 2 oxygens, over here 2 hydrogens, and 1 oxygen. How about, let's see, I'll put a 2 right here. So 2 times 2, that gives me 4 hydrogens, but 2 times the 1, that'll give me 2 oxygens. So my oxygens are balanced now, but my hydrogens are messed up. What I can do over here is put a 2 in front of hydrogen, and now 2 times 2, that'll give me 4. And now the atoms on each side of the equation are the same. This equation's balanced. Sometimes we'll have equations that look downright scary. Yikes. But if we have a polyatomic ion on both sides, like the SO4 or the NO3, then we can consider that ion to be just one thing. Let's see how that works. So here's the equation, and I've done my accounting below. You can see I have 1 calcium here, 1 calcium over here, and then I wrote the entire SO4 as one thing. And I have 1 of those here, and over here I have 1 SO4, NAs, 1, 2 NAs on this side, and over here 1 NO3, and I have 1 NO3, but that 2 on the outside means I have 2 of them. So I have 2 NO3s. So if I put the coefficient of 2 right here, that means I'll have 1 times 2, 2 NAs, but this 2 also multiplies across, so 1 times 2 for the NO3s, that gives me 2, and now everything is balanced. So by treating those polyatomic ions as just one thing, it makes it a pretty simple equation to balance. Let's wrap up with one that sometimes gives people problems. So we can see we have 1 carbon, 4 hydrogens, and 2 oxygens. Easy. Over here we have 1 carbon, and then we have 2 oxygens, and then we have 2 hydrogens. But be careful. We have to count this oxygen over here as well. So we have 2 plus 1. That'll give us 3 total oxygens. I'll start by balancing the hydrogens. If I put a 2 in front of this hydrogen, 2 times 2, that'll give me 4. And that'll fix the hydrogens. But now I have 2 oxygens plus 2 times 1, 2 oxygens. That gives me a total of 4 oxygens. But that's good, because now if I put a 2 right here and change this coefficient, 2 times 2 equals 4, and now everything is balanced. This video has given you the basics for balancing equations, but you've got to practice to gain speed and expertise. The more you practice, the easier it becomes. This is Dr. B, and thanks for watching.